Anyway, welcome back all of you to the Infinity Learn JEE YouTube channel. This is me Suya, your chemistry faculty from Infinity Learn. Okay, finally we will be moving to the third part of our chapter, Biomolecules. We will be discussing about the amino acids, right? The basic structure of the proteins. Okay, I hope you guys have revised through the topics we have covered in the last class. Without wasting any time, I am directly moved to the topic here, that is the amino acids. Before that, there is a gentle reminder about the AITS. AIT is all the test series for JEE Main Session 2 and JEE Advanced 2025. I hope all of you have enrolled this course. If anyone missed that, just enroll fast. We can discuss about the proteins. What do you mean by proteins, right? This is a type of biomolecules, right? So, proteins are the most abundant biomolecules of the living system. Most abundant biomolecules of the living system is known as the proteins. So, proteins are the occur in every part of our body and form the fundamental basis of structure and functions of life, right? So, the word protein is derived from the Greek word proteos, which means that it is a primary or prime importance. Hi Divya, good evening. Okay, these are the just introduction about the proteins. Okay, all the proteins are the polymers of amino acids, right? Whenever few amino acids monomers are combined together, we can form a polymer known as the proteins. So, amino acids is a very important topic in the chapter Biomolecules. Let us start with the important topic, that is the amino acids. What do you mean by amino acids? What will be the functional groups that are present in the amino acids? By the name itself, you have an idea, right? Amino and acids. Okay, this is a bifunctional group, organic molecules that contain amino group as well as carboxylic acid group. That is why the name stands for amino acid. Amine group and carboxylic acid group. Right? This is the basic structure of the alpha amino acids. I will be explaining about the alpha structure here. This is our amino group, right? NH2 group. This is our carboxylic acid group, COOH. So, whenever the carboxylic acid is present on the carbon atom, that carbon atom is known as the alpha carbon. Alpha carbon. So, in this particular structure, the NH2 group, that is the amino group, is present over the alpha carbon atom. So, I can call this amino acid as a alpha amino acid. Clear? What you mean by alpha amino acids? Whenever the COOH group or the carboxylic acid group present on the carbon, that carbon is known as the alpha carbon. Then towards that alpha carbon, when the amino group is present, such amino acids are known as alpha amino acids. Now let us see what are the alpha, beta and gamma amino acids along with their examples. Here is the first example for alpha amino acids. This is the very simplest amino acid present in our system, that is glycine, NH2, CH2, COOH, which means that COOH, right, carboxylic acid group, present in the case of an alpha carbon atom. Then directly to the alpha carbon atom, an NH2 group is present. This compound is known as the alpha amino acid, and this particular amino acid is named as glycine, which is the simplest amino acid present in our system, right? Now let us see here, this is our carboxylic acid group which is present on the alpha carbon atom, right? The nearby carbon atom is known as the beta carbon, then gamma carbon. Here we can say that the NH2 group is present on the gamma carbon atom, right? Gamma carbon atom. So I can call these amino acid as gamma amino acids. Right? Now, if for example, if any of the NH2 group is present in the case of beta carbon, I can call this amino acid as beta amino acid also. For example, beta alanine is an example of beta amino acid. Let us see the structure in detail in the next slide. There are few important amino acids you have to be memorized. Among them, one is the important one, that is proline. As you can see over here, the structure. In the case of all the amino acids, right? These are the amino acids. We can say that the NH2 group is present on the case of an alpha carbon. So we can say that it is a primary amine, right? This will be a primary amine. But there is an exception whenever we are taking proline molecule, right? Proline molecule. Here you can say that this is the amine group, right? This is our amine group, which is connected with two carbon atoms, right? Which is connected with two carbon atoms. So we can say that this is a secondary amine. This is a secondary amine, but it is an example of an alpha amino acids. So there is a one exception in the case of alpha amino acid, that proline, which contains secondary amino groups. Clear? I am not fluent in Hindi also, then how can I speak in Marathi? Okay, I will explain in English only, right? Okay, this is the basic classification of amino acid. Now let me move into the next part, that is the classification of amino acids based on the number of NH2 groups and COOH groups. So, here you can see there are three classifications: neutral amino acids, basic amino acids, and acidic amino acids. By the name itself, you must have an idea about what you mean by neutral, basic, and acidic amino acids, right? For example, if I am taking neutral amino acids, which means that the particular amino acid contains same number of NH2 group as well as COOH group. For example, if I am taking the example of glycine, right? Okay, this is our glycine molecule or glycine amino acid. Okay, what is the observation you can see here? Same number of COH and NH2 group, right? One NH2 group and one COH group, which means that same number or equal number of NH2 and COH groups are present here. So we can call glycine molecule as an example of neutral molecule, example of neutral amino acids, right? Clear? The next classification is the basic amino acid. What do you mean by basic amino acids? Any idea? As compared to the number of amino groups and acid groups. What do you mean by basic amino acids? Which group will be more here? Whether amino group or carboxyl acid group? In the case of basic amino acids. In the case of basic amino acids groups, amino group, right, NH2 group will be more than as compared to the carboxyl group. For example, you can see here, this is our structure of histidine molecule. This is an important amino acid you have to be noted. You can see that this is one NH2 group, here again another amine group, right, which means that more NH2 group is present as compared to the COOH group in the case of histidine molecule. So we can call histidine molecule as a basic amino acid. Clear? Similarly, there is another classification, that is the acidic amino acids, which means that the number of COOH group or the carboxylic acid group is more as compared to the amino group or NH2 group. For example, glutamate, right? This is the structure of glutamate. As you can see here, this is one COH group, this is another one COH group. So which means that the number of carboxylic acid group is more as compared to the amino group in the case of glutamate molecule. So I can classify or call it as an acidic amino acid. Is the thing clear? How we are classifying the amino acids based on the number of amino groups and carboxylic acid groups. Now let me move to the another classification of amino acids based on their synthesis, right? This is the very important classification of amino acids based on the synthesis, how they can classify. There are two types of amino acids. They are named as non-essential amino acids and essential amino acids. Non-essential and essential amino acids. What do you mean by non-essential amino acids? These are synthesized by our body itself, right? These are synthesized in our body. So these amino acids are known as non-essential amino acids. So there will be another type of amino acids which our body cannot be synthesized, right? Our body cannot be synthesized. It must be supplied through the food. It must be supplied through the food. Such classification of amino acids are known as essential amino acids. Essential amino acids, right? In total, 20 amino acids are present. Among them, 10 are essential amino acids. 10 are essential amino acids. It is very important to memorize the number of 10 essential amino acids. Right? Ready? Okay, there are 10 essential amino acids are present, right? This is the mnemonic or the trick that I am using to memorize these 10 amino acids. This is a sentence, as you can see over here. Any help in learning these little molecules proves truly valuable. As you can see over here, I am highlighting or I am changing the color of first few letters, right? First letters of every word in the sentence. A, H, I, L, T, L, M, P, T, V, right? These first letters or the highlighted letters stands for the first letters of our essential amino acids, right? Let us see what are they. Here A stands for arginine, right? Arginine. H stands for histidine. I stands for isoleucine. L stands for leucine, T for threonine, these L for lysine, then M for methionine, P for phenylalanine, last T for tryptophan and last V, valuable, V for valine, right? These are the 10 important essential amino acids you have to be remember. You can use your own numerical trick or mnemonic or tricks to find out these numbers, right? Now, let us see what are the properties of amino acids. What are the properties of amino acids? Amino acids are generally colorless, right? They are colorless crystalline solids. They are colorless crystalline solids. Most of them are water soluble. They have high melting point. And they behave like salts. These are the important properties of the amino acids. Then, Again, there is one more exception. All the alpha amino acids, right? All the alpha amino acids are optically active in nature. As you already know about the optically active nature, right? So this is the ability of the particular molecule to rotate plane polarized light. This is not the optically active. Again, one more exception is there, our glycine molecule, right? Our glycine molecule, that is okay, this is our glycine molecule. This is optically inactive in nature. Clear? While discussing about the properties of amino acids, this is a important topic, that is about the switcher ion effect, right? Switcher ion effect or switcher ion property of the amino acids. What do you mean by switcher ion, right? As we already know, in the case of amino acid, there will be two functional group, right? One is amino group and another one is the carboxylic acid group. So we can say that if I am taking this molecule, this is our amino acid structure. So amino acids can act as amphoteric, which means that they exist as cations or anions, or it can react with acid as well as bases, right? That property is known as amphoteric nature. The amphoteric nature of amino acid is explained by its switcher ion property. Switcher ion property. Okay, you can see over here, this is our NH2 molecule, right? This NH2 molecule can accept H plus ion to form NH3 plus here, right? NH3 plus here. Similarly, this COH group can release H plus ion to form COO minus group also. So at the same time, it can act as cation. This is the cationic part. This is the anionic part. So this particular ion or molecule is known as a switcher ion property. Switcher ion or switcher ion property. So it is also known as inner salt, right? So this is the complete explanation. The amino acids exist as cations in acidic medium. Whenever we are moving to the acidic medium, right? At acidic medium, it will act as cation, right? In the acidic medium, it will, amino acid, it will accept H plus ions to form NH3 plus cation here in the first case. Whenever it is happening in the base solution, right? OH minus solution, it has a tendency to lose H plus ion, right? So it will lose the H plus ion to form. Here it will lose the H plus ions to form anion, right? So this complete property is known as the switcher ion property for the amino acids, right? Based on this switcher ion property, we will be explaining the another term known as the isoelectric point. What do you mean by isoelectric point? As we already know, amino acids can exist as cation as well as anion, right? If I am taking the acidic medium or basic medium, it can react as the amphoteric nature or the switcher ion property. Based on that property, we can explain the isoelectric point, which means that at a particular pH, right? At a particular pH, the switcher ion behaves like neutral species. It behaves like neutral species. It will not migrate. It will not migrate into any of the electrode, whether it is positive or negative electrode. It will not migrate into any of the electrodes. Such point or the point at which the pH, at a particular pH, is known as the isoelectric point of the particular amino acids, right? Isoelectric point of the particular amino acids. Hi Chirag, good evening. In general, whenever we are considering about the neutral amino acids, it has the pH range of 5.5 to 6.3. 5.5 to 6.3. So, generally, the solubility of alpha amino acids is least at its isoelectric point. Isoelectric point means the particular pH. It will act as a neutral species. It cannot be moved into any of the positive electrode or negative electrode. So, that particular point is known as isoelectric point. In general, the solubility of all the amino acids, all the alpha amino acids will be very least at its isoelectric point. Very least at its isoelectric point. So, for this particular characteristic, it can be easily separated at the isoelectric point. Is that clear? Okay, congrats, Chirag. Okay, then prepare well for the advanced exam, right? Okay, let us see what is the formula to calculate the isoelectric point of the amino acids. There is a particular formula. Okay, this is our particular formula. This Pi stands for the isoelectric point of the amino acids. That is equal to pKa1 plus pKa2 divided by 2, where pKa stands for the pKa value of the carboxylic acid group. Then pKa2 stands for the amino acid group, right? Amino group, pKa of the amino group. Okay, based on this particular expression, you may get the numerical problems also. Right? So, we have seen about the isoelectric point. So, we can say that if you are considering any of the amino acids, all the amino acids do not have the same isoelectric point. Depending upon the characteristic or the property of the amino acids, its isoelectric point also changes. So, for example, if I am taking any of the acidic group, right? Acidic amino acids, which means that amino acid having more COOH group, or I can call it as the acidic amino acids, right? For that particular amino acids, the Pi value or the isoelectric point value is less than 7. Less than 7. Then what about the basic amino acids? Basic amino acids means it must contain more NH2 groups as compared to COOH group, right? So we can say that for that particular basic amino acids, the isoelectric point Pi should be greater than 7. You can remember this thing along with the idea about the pH, right? If you are taking pH, what about the pH of acids? Whether it is less than 7 or greater than 7. Chirag, I am from Kerala. Okay, what about the answer here? If you are considering acidic acid or acidic group, what will be the pH? pH will be less than 7 or more than 7 for an acid. Less than 7, right? So if you are considering the acid, it should be less than 7. Similarly, you can remember this thing also whenever we are considering acidic amino acids, right? For their pH is related to the isoelectric point. So similar to the pH also, isoelectric point will be less than 7. Then similarly for basic amino acids, what do you mean by base? Base is having pH greater than 7, right? Similarly, isoelectric point is also having more than 7 value, right? Clear? Yes, Chirag, you are correct. Is that clear? Just let me know. Okay, now let us take the structure of amino acids, right? Structure of amino acids. I have already shared that there are 20 amino acids are present, right? 20 amino acids are present. It is better to know the structure of all the amino acids in order to solve the questions. Okay, we are starting from the glycine here. This is the simplest one. NH2, CH2, COOH, right? This is the Fischer projection formula for the different amino acids. This is the first one, that is glycine. This is the simplest amino acids. right? So here is the next one, that is isoleucine. I have already shared the mnemonic, right? Trick or mnemonic to find out the amino acids. So I can say that isoleucine is a important essential amino acids, right? So whenever I am giving the examples here, the starred one stands for the essential amino acids. So this is the isoleucine structure, one of the essential amino acid. Again, tryptophan is the essential amino acid here. As you can see here, this is a amino acid in which there is a heterocyclic ring is present, right? Heterocyclic ring is present here in the case of tryptophan. Then next one, glutamine. Again, what is the specialty of glutamine here? Is it possible to express them in the new manner or horse? Just think about that. This is the simplest one. When you are moving to the other amino acids, there will be some complications, right? Okay, third one is the glutamine. Glutamine is having here, right? 2 NH2 groups are right. Glutamine is here. This next one, it is tyrosine. Again, there is a benzene ring is present in the case of tyrosine molecule. Then these are the other examples of or structures of the amino acids. First one, alanine. Alanine, that is NH2 CH3 CHCOOH. Next one, methionine, essential amino acid here. Then aspartic acid. Aspartic acid, it is the acidic one having more COH groups as compared to the NH2 group here. Serine. Lysine, again is an essential amino acid. Then what about the next one? Valine, right? Valine, essential amino acid here. Proline, this is an exceptional case. Yes, fine. Okay. Proline, this is an exceptional case, as I already mentioned that, right? This is an alpha amino acid. As compared to all the alpha amino acids, there is the one exception, that means that in the case of proline, right, this is our NH2 group, but this NH2 group is connected to 2 carbon atoms, so this is a secondary amino group, right? This should be very important. Clear? Then the next one is the glutamic acid. Don't confuse with the glutamine and glutamic acid. In the case of glutamic acid, there will be more COH group compared to NH2 group, right? So this is the glutamic acid. The next one, threonine, another essential amino acid. Arginine, again another amino acid. Then leucine, another essential amino acid. Phenylalanine, this must contain a benzene ring, right? Sometimes questions may ask based on the structure, which of the following amino acids contain benzene ring or not. Clear? So it is better to memorize these structures, at least what are the components in that, instead of amino acid and COH group, right? Then the next one, asparagine, cysteine and histidine. Histidine is the another one essential amino acid having the heterocyclic group. This is not benzene, right? This is another heterocyclic group. Is that clear? Chirag, which chapter? Okay, that's all about the structure of amino acids. Now let us practice some questions. Here is the first question for you. Which one of the following amino acids cannot be synthesized in the body? cannot be synthesized in the body? Okay, you need hydrocarbons chapter, right? Okay, let me try. Hey, what is the answer for this question? Okay, there is a humble request that if I am taking the hydrocarbons chapter, there should be attentive throughout the class, right? If I am taking the first part, second part and all, you should be attentive in the class from 5 to 6. Hi Rana, good evening. Okay, tell me the answer for this question. Yes, option A, option 1 or option A, right? Harsh. Okay. Okay, what are the particular name for these amino acids that cannot be synthesized in our body? There is a particular name, right? You have already classified the amino acids into 2 types based on their synthesis. What is the particular name for these amino acids? Yes, option A, leucine, right? Let us take the answer. Essential, right? That amino acids that cannot be synthesized in our body or supplied through the food are known as essential amino acids. So there are 10 amino acids, 10 essential amino acids are present. So it is better to memorize all the 10 amino acids, 10 essential amino acids detailedly. Okay, here you can say that among these following, leucine is the one that is essential amino acids, right? So option 1 will be the correct answer. Clear? Yes, Harsh, you are correct. Here is the next question. All the following amino acids contain benzene ring in their structure except. Options are given here. Histidine, phenylalanine, tryptophan and tyrosine. So in order to solve this question, you must have an idea about the structures, right? Okay, what will be the answer? Which are the following amino acids that do not contain the benzene ring in their structure? Histidine, right? Histidine. Okay, I hope this image was visible to your screen. Okay, this is our histidine structure. This is a COH group. This is a NH2 group. Okay, this is the COH group. Okay, this is the NH2 group. There will be a heterocyclic ring, right? There will be a heterocyclic ring. Right? So in the case of histidine, there will not be any benzene ring. There will not be any benzene ring. So we can say that option 1 will be the correct answer here. Do you want to check the structure of another acids also? Phenylalanine, tryptophan and tyrosine. Phenylalanine, right? There is a benzene ring here. Then tryptophan. Again benzene ring, right? Tryptophan, benzene ring. Then tyrosine. There is the benzene ring, right? So the only one example is the histidine that does not contain the benzene ring in their structure. Clear? Here is the next question. Based on the optical activity of the amino acids, which of the following alpha amino acids is not optically active? Not optically active. Otherwise, which among the following is optically inactive? Option 4, right? Okay, glycine. What is the structure of glycine? Yes, it is in NCERT, right? Yeah. Okay, this is very important question. Glycine, right? Okay, this is the structure of or the molecular formula of the glycine molecule, right? So, how we can derive the optical activity of a compound? I hope you have studied about the stereochemistry, right? Why we can say that it is not optically active? What is the reason behind that? Any idea? Harsh? Okay, fine. Optical activity is based on, yes, no chiral carbon, right? Yeah, correct. Optical activity is based on the chirality of the carbon, right? So, what do you mean by chiral carbon? What is the definition behind that? Yes, no chiral carbon or achiral carbon, right? Yeah, correct. Then, if I am taking this carbon atom, right? If I am taking this carbon atom, whether it is achiral or chiral, how we can define the chirality of a carbon? Just recall the topics you have studied in the stereochemistry chapter. Yes, correct. Great. This is the carbon atom, right? In order to predict the chirality of a carbon, carbon contains 4 valencies, right? Carbon should attain 4 valencies. So, in order to maintain the 4 valency, if it is contained 4 different groups, right? If it is contained, for example, I am taking here, just for a representation. So, this is our carbon containing 4 valency. Carbon has the tendency to form 4 bonds with the 4 different groups. So, if I am taking A, B, C, D groups, I can say that A, B, C and D groups are different, right? So, we can say that, yes, fine. So, I can call this carbon as a chiral carbon, right? Then what about the glycine molecule? How we can say this is not a chiral carbon? So, if I am elaborating this carbon, I am just writing like this, right? This is CH2COH, right? Which means that the same carbon contains 2 same hydrogen atoms, right? So, there is no any 4 different groups attached to the carbon. So, I can say that this carbon is achiral or non-chiral. Achiral carbon. So, based on the achiral property or chirality, we can say that it cannot form the non-superimposable mirror image, right? That will be the definition for the stereoisomerism. So, it will not form the non-superimposable mirror image because of the lack of optically active or the chiral carbon. So, I can say that this particular molecule or the glycine is optically inactive in nature. Clear? Is that clear? Okay, great. Here is the next question based on the isoelectric point calculation. The pKa1 and pKa2 value of alanine, the amino acid given is alanine here. It is given as pKa1 is equal to 2.3 and pKa2 is equal to 9.7 respectively. The isoelectric point of alanine is. Values are given here. Just put it on the formula. You will get the answer. What will be the answer? Option 2, right? Okay. How we can calculate that? What is the formula behind that? Yes, option 2 is the correct answer. So, Pi, right? Pi stands for the isoelectric point. So, I can take it as pK1 plus pK2 whole divided by 2, right? Here pK1 stands for the pK value of the carboxylic acid group and pK2 is for the amino acid group, right? Amino group, NH2 group. So, here the value is given 2.3, right? pK1 is 2.3, pK2 is 9.7. By taking half of this value will become 6.0 or simply 6, which means option 2 will be the correct answer. Clear? Yes, correct. Based on this particular topic or the isoelectric point, you may get the questions like whether it is acidic or basic, right? If the isoelectric point is greater than 7, what will be the character of that amino acid? If the Pi value is, okay, for example, if I am taking alanine, whether it is acidic or basic amino acid based on the Pi value, what is the nature of this alanine amino acid? Pi value is 6, right? Pi value is 6, which is less than 7. So, we can say that alanine is an acidic, right? Alanine may be an acidic or basic. Compare with the pH value. If the pH is less than 7, what will be the nature? Yes, this is acidic, right? So, compare with the pH value. If the pH is less than 7, we can say call it as the acid molecule, right? Similarly, in the case of amino acid molecule, we are connecting it with the isoelectric point. When the isoelectric point is, okay, previous question. Okay. When the isoelectric point is less than 7, we can call it as the acidic amino acid. If it is greater than 7, it will be basic amino acid. Here it will be acidic, right? Clear? Clear? Okay, fine. I have asked already if pH greater than 7, then it will be basic, right? You are right. Okay, here is the next question. Select the essential amino acid that has heterocyclic ring. Already options are given here: valine, glutamic acid, tryptophan and phenylalanine. Just recall the structures of amino acids. Which one contain heterocyclic ring or other than benzene ring here? Option 3, right? Yes, option 3 is the correct answer. That is tryptophan. Yeah, you are correct. Okay, what will be the structure? This is a structure, right? This is a structure of tryptophan. So this is the carboxylic acid group. This is the amino group. Then it is connected to the another heterocyclic ring, which is again contained in the benzene ring, right? Okay, another heterocyclic ring. So we can select the essential amino acid as the one having heterocyclic ring is tryptophan. Clear? Option 3 is the correct answer. Okay, here is the next question. I think this will be the last question from this session. Okay, what is the answer for this question? Select the essential amino acid with heteroaromatic character. Heteroaromatic character. Okay, I believe everyone have the idea of aromaticity. We have studied about the aromatic compounds, non-aromatic and anti-aromatic compounds, right? Whenever we are considering the heterocyclic rings, it must have the heteroaromatic character. So you have to identify the one essential amino acid with heteroaromatic character. Okay, what will be the answer for this question? Option 3, right? Okay, if you are checking with the previous question also, we can say that this is the same repetition of the question. Only the question is twisted that it contains heteroaromatic character, right? Okay, in the previous question, it was like which one containing heterocyclic ring. So no need to get confused. Heteroaromatic character as well as heterocyclic rings. Ring means the same property or same character. So we can say that again tryptophan is the same molecule because of the presence of these heterocyclic ring, right? Because this is having heterocyclic ring, so they have the heterocyclic aromatic character or heteroaromatic character. So tryptophan, option 3 will be the correct answer. Is that clear? Okay, fine. Okay, network issues are there, right? Okay, fine. Okay, this is all about from my side for today. We have studied about the starting of amino acids, right? We have studied about the proteins. What do you mean by proteins? It is the essential combination or the essential biomolecule which is present in our body. So, while starting from the proteins, we will be studying about the structure of amino acids, right? Amino acids are the monomers of the polymer protein. So, we have discussed about the classification of amino acids, right? Starting from the classification of amino acids, there will be there will be the different classification based on the amino acid groups, right? Two bifunctional group containing amino group and carboxylic acid group. So they are called the amino acids. There will be based on the presence of NH2 group on that, we will be classifying the amino acids into alpha, beta, gamma amino acids depending upon the position of amino groups. Then the next classification is based on the number of amino groups and carboxylic acid groups. Based on that, there will be 3 classification: basic, acidic and neutral. Okay, basic, acidic and neutral. Yes, basic, acidic and neutral amino acids, right? So, you must be remember about the examples along with the amino acids. Then, the next important classification is the essential and non-essential amino acids. There will be a simple trick to calculate, to memorize the 10 essential amino acids. You can use your own trick to memorize these amino acids. This is the trick I am using to memorize these amino acids. Okay. Now, another we are moving to the properties. Properties we have to be identify about the switterion property, right? Yes, it will form switterion. This is a switterion property or the amphoteric nature. Amphoteric nature means it will react with both acid as well as base, right? So, whenever we are considering about the amino acids, this amphoteric nature is explained by the switterion property, right? Switterion property. As you can see here, whenever the amino acid is reacting with acid, right? Whenever it is reacting with acid, this NH2 group present in the amino acid will accept proton, right? It will accept proton to form NH3 plus cation. Similarly, whenever it is reacting with the base molecule, right? It has a tendency to lose H plus ions to form anion. So, this property is known as a switterion property. This is very important in case of properties of amino acids. Clear? Then finally, we are moving to the structure of different structure of amino acids. You must be remember about the structure of amino acids along with their particular structures, right? If they contain a heterocyclic ring or benzene ring, if they are simple amino acids or something, right? Clear? Okay, fine. Now, I will be coming back with the next session by using the structure of proteins. We'll be discussing about the structure of proteins in detail. So, till then, bye-bye all of you. Then, if you like this session, just share this session to your friends and family also. Then, like and subscribe our channel. Okay, see you tomorrow in the next class. I mean the same time from 5 to 6. Till then, bye-bye all of you. Thank you so much.